what you should understand that in your chemistry practical is going to be based on two topics. One, we have something called quantitative analysis. Quantitative analysis. And second, we have something called qualitative. Though with this quantitative, there are three types of quantitative analysis, but I'm not going to go into all this one. I'm going to go specifically to exam. So in this quantitative analysis, the experiment we have to do is an experiment which is known as volumetric analysis. Volumetric analysis. And in brackets, we call it titration. And in this qualitative, the experiment you'll be asked on is on something called the salt analysis. The salt analysis. So I'm explaining this titration. And the titration experiment that you'll be doing, which is an experiment. So the titration experiment you'll be doing, which is the experiment, there are some apparatus that will be used, that you'll be given. Let's say the apparatus you'll be given. So in this apparatus, there's something we call a beaker. Or either they give a beaker or they give a conical flask. 2, you'll be given a redox stand. A redox stand. 3, you'll be given a funnel. Yeah, funnel. 4, you'll be given a pipette. Or you call it a pipette. Also, you'll be given a burette. We have burette. And then which other one? Is burette. So these are the apparatus you do. And I think sometimes they can give you a filter paper. This one is not all the time. They give you a filter paper. Just in some cases, you give you a filter paper. And in all this experiment, you also be given something called a reagent, which is more like your chemicals. So you give reagents, and this reagent, we have your reagent A, which is an acid. When you see something in a beaker and you label it, you put A. So once you see it A, you should know that it's an acid. And you also give a reagent B, which is known as a base. So you're given a reagent which is an acid, and also you're given a reagent B, which is a base. And also you're also given something called an indicator. So these indicators, the reason why you are given an indicator, the indicator is for you to is used in order to detect a color change. You use it to detect color change. Use it in detecting color change at the end of the experiment. And this indicator for your own experiment can give you about 4 or 5 of them. Then number 1, we have your methyl orange, or methyl red. You give methyl orange or methyl red. You also be given a litmus paper. You might be given a litmus paper. You also be given maybe a phenolphthalein. So all these 3 are the basic ones that they give for right practical. You know, there's also something called the crease of blue. There's also other ones. So but the main ones will be the methyl orange or methyl red. You also be given a litmus paper. You also be given a phenolphthalein. So one thing about this experiment is for you to measure, for the word volumetric analysis, volumetric measure. So it is a measurement of volume. So volume of either an acid or a redox reaction. So we call all these things when we use it in solving for an acid or an acid-base reaction. So the next thing you should also understand is that this indicator, I said they always use in order to detect the color change in an acid-base reaction or a redox reaction. So you must also understand what are the color changes that you observe in this acid-base reaction. So the indicator color changes. So let's say we have a table. So there's a table. In this table, we have our indicator. So after the indicator, what will be the reaction in an acid? What will be the color change in base? What will be the color change at neutral point? Neutral point means at the end of the reaction, what will be the color change? Do you understand? So for indicator, let's do litmus paper. So if you put litmus paper in an acid, you always have the color red. And if you put litmus paper in the base, you always have the color blue. If you put litmus paper at the end of the reaction, you realize the color will change to what? 4. 2. This is methyl orange. For methyl, this is for litmus paper, sorry. So for methyl orange or methyl red. For methyl orange, methyl red, if you put it in an acid, the color is going to also be red. If you put it in the base, you have yellow. And if you put it at the end of the experiment, it's going to be orange. And for the last one, which is your phenolphthalein. So phenolphthalein, if you put it in an acid, is always colorless. If you put it in the base, the color is pink, and at the end of the reaction, you always have a colorless color. So these are the color change you also need to know of that. Look, you also need to always observe that probably in the acid base reaction, if you put litmus paper in an acid, you have red. If you put it in the base, you have blue. If you put it in neutral point, you have purple. If you put a methyl orange in acid, you have red, in base you have blue, and put drop point, you have orange. Also, the phenolphthalein, you put in an acid, you have colorless, put in a base, you have pink, put in a neutral solution, you have colorless. Okay, so if you look at this is a titration setup. So this is how the cell is going to look like when you are doing your real experiment. So this is the little stand I was talking about. This is the little stand. This is the phone that is put inside the bullet. And this is the bullet. This bullet, there is an acid inside. You see, so inside the bullet there is an acid. And the bullet also has a clip, or sometimes you call it a tongue, and you use it in opening and in closing. You close so that the acid does not drop, and you open anytime you want the acid to enter into the conical flask. You can see the conical flask. Inside this conical flask, in this setup, there will have been an acid and an indicator. And the indicator, you have to make sure is, you only put 2 or 3 drops of the indicator inside this conical flask. That's the base. So this is also another beaker, or it can be a conical flask where you label it as A, and the A should know it is an acid. An example, if I don't put A, they might put HCl, they might put H2SO4, they might put HNO3, they might put CH3COOH, and this is another one where the label as B. You might not put B, they might put KOH, which is potassium hydroxide, sodium hydroxide, calcium hydroxide, or aluminum hydroxide. So this is the base. You use base in sorting base, and this is a pipette, so a pipette, and you use the pipette in sorting base. So how do you perform this experiment? In this experiment, the first thing is that you begin an acid and a base. So the first thing you do is you carry the base, or precautions. Number one, maybe you might not just, in this beaker, you wash this beaker, you put acid inside, you wash it either with an acid, just rinse it a little with an acid. This beaker, that will have a base, you also wash it with the base. What I mean is that all the apparatus, you wash them with the reagents that are supposed to be inside them. So in that instance, you wash the beaker that you put acid inside with an acid, you wash the one you put the base inside with the base, including the pipette, you also wash it with the base. This is the base of the inside. And also this bullet, you can also rinse it with an acid. You can also test this tap whether it's not leaking or it's leaking, you understand? Because if it's leaking, it will always affect. The reason why we are doing this is because the reason why you are washing all these apparatus with the reagent that's supposed to be inside them is because this thing wants to measure volume. And if you add water, if you wash, let's say, this beaker is supposed to have an acid, if you wash it with water, anytime you now put an acid, the responsibility is going to dilute that acid. So the acid becomes diluted. And once the acid becomes diluted, you need to get the exact concentration that you need in getting. So the first thing is you have to wash out them with the reagent that's supposed to be inside the next precaution. Number 1. Number 2, you now pick up this base. When you pick up the base, you then take the indicator. You now take all this indicator, this most paper, they can give you most paper, they can give you methyl orange, they can give you phenolphthalein, and they can give you methyl red. So you just add 2 to 3 drops, 2 or 3 drops, anywhere you like. If they say in the instruction you can put add 2 drops, in the instruction you can say add 3 drops. So if they say add 2 drops, just put 2 drops, bam, bam. If you put 2 drops inside this base, then you just shake the base a little bit. If you shake it, you realize that there's a color change. So once you realize there's a color change, no problem, you leave the base. You now bring the base here. Are you following? So you bring the base to this place. When you bring the base to this place, you might not even bring the base to this place, you see it here. Then take the funnel, put the funnel inside this bullet, and then you can pour acid inside. Gently, pour it gently. Precaution number 2, make sure this little stand is not too more than the height. For instance, if this is me and this is setting, and I want to pour acid, you can see this one is 60 for 2 volts, pour acid. But if it's too much, the responsibility that I try to make, if the height is too big, it's too high, we are trying to pour acid now. Imagine my hand is just shaking and somebody just push you, it's the responsibility that I can pour the acid on my body. So you have to make sure that the setup that you have created is not too taller than you understand. It is in your own maximum height, your reachable height at which you cannot reach, you can easily reach out. So you have to be careful. So while you pour the acid, into this burette, it will be close. You fill the acid up to the last measurement. Now, when you are pouring, this is where my precaution comes. Number 1, you have to make sure you avoid anything that's called air bubbles. That means when you are pouring, let's say these burettes are usually on course. Probably when someone is taking drop and you are pouring water, so you don't realize that there's one part here. You'll be seeing water. So you just see one part. Maybe one part like I have one small circle. You see that there's nothing in this. This is looking like a circle or something like that. There's no air that is entering into this place. So this is what we call air bubbles. So you have to make sure you avoid these air bubbles. And how do you avoid it? You just open the tap. So when you open the tap, all these water you can dry up and you come to this point. Once the net has come to this point, you can close the tap up and try to fill it. And while you are filling, just fill it gently. And you pour the acid into the burette gently, don't rush, so that the water does not jump again. So you avoid air bubbles. And when you are pouring it inside, you make sure you fill it to the last measurement, which is always the pep. You can say it's 25, you can say it's 20 centimeter cube. So just make sure you fill it to the last point. So when you fill it, number 2 is now after you fill it, precaution number 3, remove the funnel. Don't let the funnel be inside. When you are trying to pour the acid into the base, that you've added the indicator, so you remove the funnel, because the funnel can take some part of the water, you understand? And when it takes some part of the water, it could affect the measurement, or the water can be there and it will just be dropping. Remember, you try to remove funnel, that's what you do to identify the exact volume of the acid in the burette. So you always make sure you remove the funnel. So when you remove the funnel, you get the measurement. Number 3, when you are looking at the measurement on this burette, make sure you avoid error due to parallax. What does error due to parallax? Parallax means it means you have to look at all these measurements on the burette. You don't look above the burette, and you don't look like this. If you look like this, especially this water that is inside this transparent glass, so it's time that measurement. You don't look below, you don't look in a slanting position. Make sure you stand straight. Let your head be straight to that burette, and you look at it straight. Let your head be straight. So once you look at it straight, you need to get the measurement direct. You understand? So that one we call it avoid error due to parallax. So that's a precaution in that one. So once you do that, then you can bring the base. Like if added the indicator to the draw, put it on that here. You put it on that here, then you start holding it up. You hold it gently, you don't want it to place any gently so that this one can drop into it. So while you hold it, you take the base that has the indicator, like added the indicator to, so you start shaking. As well as the acid is dropping inside, you just be shaking. You're waiting for another color change, because the color will change again. You remember, I give you a thing in the first instance. So once you start shaking, immediately you see the color change, close it down. So when you close it down, this acid would have reduced. You know, if the acid is at probably at this top, you know, when you feel it, the acid will have been at the top, at this top. So by the time you release it and start dropping, it will have reduced to maybe here. So it will have reduced to this point. So the next thing is now, remember, you now measure the volume at this place. So let's say when you feel it at the beginning, you feel it at let's say 0.00. So by the time you now check the measurement, now falls to let's say 24.50. So you must always make sure you take note of this. So once you are the time you color change, you will repeat the experiment 2 to 3 times. But then you repeat it 2 to 3 times. So I'll give the next time I'll give you the table that I'll use in identifying the acid. Also remember this base, we use the base to take this pipette, use it in sucking the base. That means at the beginning you take the base, put it inside the pipette, put it inside this base, and then just check the measurement and then use it to just suck the base. They always tell you the volume that you saw, volume of the base. Sometimes they can tell you something 20 centimeter cube, or you say use 25 centimeter. So you'll be given this one is always constant 20 or 25 centimeter cube. So the next thing I'll draw a table that you always form for this chemical experiment. So the table that you're going to, after you have performed all those experiments, so you're going to have a table, and the table is going to be like this. So in the table, this place we have the readings. This table you always draw it to be very, very compulsory. You get. So this table, there's something that the readings. After the readings, there's something you have rough titration. See, in your exam you can write the word titer. Because you are smart, you don't write titer, write titration, not first titer. You can write rough titer, you don't write titer, make sure you write titration. So you have rough titration, you say first titer, you don't write titer, just put first titration. They also give you more like second titer, second, you don't write titer, write second titration. Smart, yeah? That way, that's how one ways you can use to differ from every other person. And if the examiner is making a question, you know that, oh, I think this one is very, very smart, and this one is very wise, and she knows what she's doing. So, if you have this reading, there's always something called the final burette reading. We call it the final burette. Final burette reading. This thing, put in bracket, centimeter cube. Always make sure you put it in. Then, after this final, we now have something we call initial burette reading. This one too, right? Centimeter cube. Draw like this table. Then after this initial, there's something we call volume of acid used. Volume of acid used. Put this one too in bracket. Centimeter cube. It's all these things. Make sure you follow them very well. Don't miss anything. Don't say, oh, there's no time. You're now shortcutting it. Don't shortcut it like every other person that will do the exam. Write them, write them. That way, the examiner will know you are different from every other person, and they will just give you a full mark. Now, what you should know, one thing you should note is that all your reading, all this reading that you put in this table, all the numbers you put here, they must be in 2 decimal places. 2 decimal places, I mean, if let's say you have 14.90 or 24.5, just put 24.50. So all of them, every single thing that we here must be in 2 decimal places. That's number 1. Number 2, any reading you get here, because it's the word rough titration, it means you might not use it. Let me give you a cheat code. It means you might not use it. So one thing is, I can always formulate a number that can formulate any figure because it's my experiment, but I would not advise you to formulate figure because it is wide. So you always want to put it in a group. So you just find like maybe 5 or 6 people. It's the 6 of you that formulate number. But one thing I want you to know is that any number that you write at this volume of acid use, any number you put here, that number, the number must not must not be more than 0.5. Any number you write must not be more than 0.5. If the difference between all these numbers that will be here, especially this first item and second item, any number that will be there must not be more than 0.5. So let's say when you do this one, you get 24.5. This one that's going to be here, let it be 24.40 or 24.60. So if you try to like subtract the two of them, you see that the difference between them is 0.1 centimeter. Yeah, so you must make sure the whole measurement is around 0.1 centimeter to 0.5. If the difference is more than this, you fail. No matter how you do the experiment, either you do the experiment or not, you always get the wrong answer, because already you've already set a particular number that all of you must get, and the averages at which you can get this number. So you must make sure that the difference between any figure that's going to be here must not be more than 0.5. It must be between 0.1 to 0.5. So I got this from this figure. For this one, I can say I have 49.50 and I use 0.00. And here, because I need 24.5, I can put 24.50, and in this place I'll put 0.00. So here, because I need 24.60, I can only put, let's say, I can say this place is 24.50, and this place I'll now say is 46 point, I'm coming out, I get 24, this place, I need this place is 24.60, so this one is going to be 24.50. For that, like 48, so 48, so it's going to be 0.6 plus 5. 6 plus 5 is 11. So 1, I bring here 8, 9, 9. So that then 3 go down there. 5, yeah. This one going to be like 9. This one like 4. So this place 9 point, this one number 1. This one will be 1.9, then 59. So this 59.10 minus 24.50 to give me 24.60. So this is the table I can always use. This one to give me 49.5%. So if you notice in this video, you know how we're able to get the volume of acid used. You can say I just say the final directory minus initial, give me the volume of acid used. This one minus this one, give me this one. This one minus this one, give me this one. So one thing you notice is that this one, the two of them, the difference between them is not more than, is between 0.1 to 0.5. So because the difference is not really more clear, this table makes sense. So after you have gotten this, one thing you should know that they can now ask you that find the average theta value. They can say find the average theta value. You see, the average theta value is always determined from this volume of acid use. We call it average. Find the average theta value. So this average theta value is what we know as VA. So the average data, how can I get the average data value? You have to get the average data value of this one. Though in this table you can have thought titration. I don't know anything they give you in school, so you can put thought titration any amount. But you have to get the average data value. I don't use this rough, and I don't use it because it's rough. You understand? So anything like rough is not necessary, it's just possible. So you have to get the average data value. Just use the value for this first titration. So you just say 24.50 plus the second one, 24.60 divided by how many are the 1, 2 divided by 2. So if I do the two of them, I'll have that'll be I think 59.1 divided by 2. So if I do it, I'll get an answer. So this answer is the VA. The VA is the answer that I get in this calculation. You understand? So if I've gotten this answer from this calculation, I've understand my VA. Now the next thing is now the other calculations that are used in titration. I hope you can get this table now. So let me write the other calculation that you now need in solving. So you'll be able to solve probably question 1A or 1B or anything. So let me show also this formula that I need to understand. Let me just show you this one before I'll solve this last question. So the formula is that remember in stoichiometry, mole is equals to concentration. Concentration in and times volume. So if you have to follow this, it means the concentration, which is the mole per dm is equals to mole over volume. So if I have this, I can also say this is also like concentration in mole per dm equals to the mole is mass over molar mass. So which means mass divided by molar mass divided by this volume. You understand? This is like mole divided by volume, like something. So which means in this place I can say concentration in mole per dm equals to, this one can be mass over molar mass times, you know, this volume over 1, so it becomes 1 volume. If I change the right times, it becomes 1 volume. So this means concentration in mole by dmq is going to be equal to mass over. Now I can switch this one here, which is mass over volume times 1 over molar mass. This is the same thing. This is mass times volume, mass volume, mass over mass volume. This is mass over mass times volume, mass over mass over mass volume. So one thing you should understand is that once I've done this, I can say concentration in mole per dmq. Because this is mass over volume, it becomes more like mole over volume, which is concentration mole per dmq. So this will become concentration now. In mass is measured in gram, so gram per. So it becomes gram per dmq times 1 over molar mass. Do you understand? So this thing becomes concentration. This is what I'm going with. Remember, concentration in mole per dmq is now equals to concentration in gram per dmq. In gram per dmq divided by molar mass. This is the formula I want to speak for. So concentration in mole per dmq is concentration in gram per dmq by molar mass. And that was multiply this in this concentration in gram per dmq will be equals to concentration in mole per dmq times molar mass. So you should also note this formula. So this is just the derivation of that, this formula I want you to understand. There's nothing hard. Just know that concentration in mole per dmq is equal to concentration in gram per dmq by molar mass. And concentration in gram per dmq is equal to concentration in mole per dmq times the molar mass. So let's now solve one question on the past question. So if I solve that question, you'll be able to understand the concept of these things. So outside the page for this question is the past question 2022. So this is the past question 2022, and you see the question, is it 2020? You see paper 3 practical question. So you see them here. So in this question they said A is a solution containing 5 grams. So let me just write some of all these things that they are saying here. So there is A. What is A? Acid. So A is said it has 5.00 grams of HNO3. So you can see A, which is HNO3. If you go and check back, you remember when I was talking about acid, I said there's HCl, there's H2SO4, there's HNO3, there's CH3COOH, ethanolic acid. So there's 5 grams of acid. You know this is mass in 500 cm in 500 centimeter cube. So it means the volume of acid is 500 cm. So this means this is the mass, and this one means this is the volume. So the next thing, I said B is a solution. B is not a solution of NaOH. So B is sodium hydroxide. Remember I said that B is sodium hydroxide. So they said put A into the burette, blah 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 blah. Then they give us a chemical reaction. So in the chemical reaction we have HNO3 plus NaOH, and this one gives us NaO3, NaNO3 plus water, H2O. So this is the equation of the reaction. So in this thing they said tabulate your result and calculate the average volume of acid. So they said I should tabulate my result and I should find the average volume of acid. So remember that in the table, you draw a table, that's the first thing. In the table, here you have your readings and your readings. There's in this place there's final, don't forget it, final correct readings, which is a centimeter cube. There's after final is initial. So initial correct readings is also the same thing. There's now volume of acid used, that's V, which is also in CMQ. Don't forget, so all these things, that's what you mean by tabulate your result. So tabulate what you have. So when you tabulate, you have you are able to put off. Let me just go straight to the point. First, titration. Then, second, titration. So I'll use some of the results that they put in this place 22.6. They use 22.6. And they use. So you know, since this was 22.6, it's actually increased by 0.1, they decreased by 2, and put 22.50. So this one becomes 0.00. Don't forget, 2 decimal places, 0.00. So this becomes 22.60. And this becomes 22.50. So after putting this, they say I should find my so I'll look for average volume of acid used, in brackets VA. So to get that, I have to add these two together. First addition, second addition, so which is 22.60 plus 22.50 divided by 2. So if I do this, I should get I'll get
So now that you can see the volume of acid has been gotten as 22.5 So let's move on to the next thing. The next question is given in the question. So and then have this. So in the question, so from the result calculate the right? So I already get the volume of gas in this. So the next thing is say find the concentration. So figure one. Figure one. Find the concentration of A in mole per dm cube. Let me divide this so I can use this and this. So find concentration of A. You remember, we find volume of acid, right? Which means volume of acid now is going to be I think 22.50 there. I don't 22.5. So our volume of acid is 22.50. Then here from the question, you look at it, you realize that volume of the base is going to use 25 centimeter cube. So from that, the mole of the acid, this is the acid in the chemical reaction. So the mole of this acid HNO3 in this reaction is 1, and the mole of the base in this reaction, just look at this left hand side. So what is in front here is 1. You know what is in front here is 1. So mole of the base is also 1. So concentration of acid, we are not doing, so that's what we say we should look for. So concentration of acid in mole per dm cube. Remember that concentration in mole per dm cube is equal to concentration in gram per dm cube over the molar mass. So how do I get the concentration in gram per dm cube? You know, concentration in gram per dm cube is what? The mass over the volume, right? So the volume has to be in dm cube, which means I times 1000 over 1. Or I divide the volume by, let me just say, okay, I have to divide the volume by 1000. So divided by the molar mass, this HNO3, so I have 1 plus nitrogen is 14 plus, you know, oxygen is 16, so 16 times 3. So concentration in mole per dm cube. So this concentration in mole per dm cube equals to, what's the mass? They give us 5. So 5 divided by 500, which is divided by 1000. Then all this is divided by 1 plus 14, that's 15, then 16 times 3. Then the molar mass is going to be 63. So everything here is 63. We do the calculation here. So this is going to be like, you know, 0 cancel 0, 0 cancel 0. So we have 5 over 10, which is 5 divided by 0.5, right? 5 over 0.5 times, so this is beyond over 63. So if you do this one, you do the calculation, you realize that the concentration is going to be like, the concentration will give us 0.159. So we have 0.159 mole per dm cube. You do the calculation, you get this. So that is the concentration of acid in mole per dm cube. So in the next question, we said find the concentration of base in mole per dm cube. So come out that soon. We are looking for the concentration of the base in mole per dm cube. So concentration of B in mole per dm cube. Don't forget I told you to find concentration of B, say concentration of A, B, CAB equals to CB, VB, which is equals to NA over NB. Then where CA equals to, you understand, write all these things, you must write them. So here, from this thing I can derive that CB equals to CAVA times NB over, VB NA. So CA, which is concentration of acid, you can see, is what we got here, 0.159 times volume of acid, say there, 2.50 times mole of the base, 1 over VA, volume of the base, that's 25 times mole of the acid, 1. So if you do all these things, you press it in your calculator, we'll have 0.143 mole per dm cube. So I've got it from Roman figure 2. So in Roman figure 3, we got concentration of base in gram per dm cube. Roman figure 3, that's actually for concentration of the base in gram per dm cube. Okay, concentration of the base in gram per dm cube. Yeah, it's concentration of acid. So remember from this formula, concentration in mole per dm cube is concentration in gram per dm cube times molar mass, which means concentration of gram, which means this concentration that we are looking for of base in gram per dm cube. You know, concentration of gram in, concentration of the base in gram per dm cube is what? Concentration in mole per dm cube times the molar mass, which will be equals to concentration in mole per dm cube for the base. That is it, concentration of the base. This is what we got here. Is 0.143 times the molar mass of the base. The base is what? NaOH. So let me look. Na is 23 plus oxygen is 16 plus 1. So this will be equals to 0.143 times 23 plus 16. That's 39. 39 plus 1, that's 40. So you will do the calculation of this one. You get 5.72. So we have 5.72 gram per dm cube. Then from figure 4, they ask us to look for the said what is the mass of NaNO3, MaNO3, if, so you have seen this one, let me write down. Let me write down. I think you should be able to see this one very well. You can pause it and see, look at it. Then, now.
Okay, so the next one, which is Roman figure 4. So Roman figure 4, let me write this one. We have HNO3 plus NaOH to give us NaNO3 plus H2O. So if we have this, so we are told that what is the mass of NaNO3? We are looking for the mass of this guy. Give 250 cm cube of NaOH. So the volume of this one is 250 cm cube. You know, I can divide this by 1000. So if I divide it by 1000, I have 0. This one comes to this one. So that will be 0.025. No, 0.25. That will be 0.25. So you have this in dm cube. Now, so what else? You neutralize the molar mass of NaOH. So they're giving us the molar mass of this one to be 40 gram per mole, and the molar mass of NaNO3. So they give us the molar mass of this guy to be 85 gram per mole. So you remember, in this case, I can find the mole. Mole is give us concentration times volume. So concentration from here, we got to the concentration before. We're going to check on it to see. I think the concentration we got was concentration of the base. What do we get it as? I think 0.143 or something. 0.143 times this new volume now, 0.25. So if you times this one together, I think we should have 0.0358. 0.0358. So we have this. Since this is the mole of NaOH, so look up. This 1 mole of NaOH gives us 1 mole of this guy. You understand? So if the two of them have the same mole, then I can say the mole of this one too is 0.035. So from here I can say mole is what? Mass over molar mass. So mass from here that I'm looking for equals to mole times the molar mass. So the mole for this one will be this one, which is 0.0358 times the molar mass. They give us the molar mass, which is 85. So if I multiply this one together, I'll get 3.04 gram. 3.04 gram. And this marks the end of this sheet. You should be able to now look at the back. This formula for stoichiometry, so that you don't make mistakes. So you don't just look like where am I getting this formula from? You should know that mole is equals to mass over molar mass. Mass is always measured in gram. Molar mass is measured in gram per mole. That's formula 1. Formula 2. Mole is equals to mass over molar mass, concentration in dm cube, in mole per dm cube times volume. This volume is also in dm cube. Or mole is concentration. This concentration is in mole per dm cube times volume. The volume is cm cube. You now divide it by 1000. So if the volume is in cm cube divided by 1000, so that's another formula. Number 3, we have mole equals to number of let me write it since you saw this one. Let me go with the number of particle divided by 6.02 times 10 raised to the power 23. So all these particles, they can be atom. Maybe here, what's the number of atom? That's the particle I'm talking about. They can be molecules. Like they ask how many molecules of oxygen can you get from something. They can be proton. You understand? They can be electron. They can be neutron. So this is Avogadro's constant, 6.02, and sometimes you can read the Avogadro's constant as something like a bit. So the fourth one, you can say mole is equals to volume over 22.4 dm cube. So this is volume at STP. So if they give you a certain volume at STP, they tell you, calculate the volume of this at STP. You have said STP, standard temperature and pressure. So this is mole, the formula for mole. Number 5, you now have mole equals to pressure times volume over rate times temperature. So this temperature is in Kelvin. So you should take note of all this formula. These are the stoichiometry formula that you can use in solving more questions on this experimental chemistry. So maybe I'll send you another video that talk about the qualitative analysis, which we usually call the SALT analysis. So I hope you're able to understand this one. And if you have any question, make sure you just text me.